Hi, my name is Tom Van Laan, the CEO and founder of CloudCalc. Today I'm going to give you a quick overview of our structural analysis product. I will be showing you how easy it is to model and analyze a steel structure using CloudCalc. In the course of doing so, I will point out some of the powerful features such as device independence, collaboration, and support for mobile devices that make our product unique compared to other PC-based software that you may have used previously. One advantage of CloudCalc is that you can access it, along with all of your models from just about anywhere you may be, using just about any browser on just about any device, including PCs, Macs, tablets, and phones. You can sign in seconds, or if you don't yet have an account, you can get licensed in under a minute. And the product may be licensed for durations of 1 month or more to precisely match your project workload. Once in CloudCalc, you see that the product operates similarly to other PC-based software. You may build or edit your model by typing in data here in the data entry sheet, or you may elect to model it graphically or through any combination of both methods. CloudCalc analyzes structural steel for both static and dynamic loads, including modal extraction and response spectrum. The resulting loads and stresses are evaluated against either the ASD or LRFD provisions of the AISC code. One major benefit of CloudCalc is that we support intra-project collaboration, making it easy to share your models with colleagues, even if they do not yet have a license of CloudCalc. In addition to letting you build models from scratch, we also have interfaces such as CIS2 and SDNF that allow you to import from most popular design applications. Our online database contains over 12,000 steel members from standards such as AISC, British, Indian, Mexican Steel Joist Institute. And of course, our program has extensive help facilities, including a video library to make you an expert quickly. And finally, the frequent product updates are applied automatically without you ever having to wait for your IT staff to intervene. Okay, let's see how easy it is to build and analyze a steel model. We'll first create a new model and give it a name. We'll call it new. As mentioned, we could build the model from scratch, but here we will elect to start by importing our structure from the CIS2 file produced by some steel design software, in this case, CADWorks Structural. We see that all the geometry and the individual properties, including member type, anchorage, end conditions, come across accurately. In fact, the model may be fully ready to analyze at this point. However, oftentimes a structural engineer may wish to make some modifications first, so let's do just that. First, we'll add anchorage to the base of all these columns. Simply select the columns, select restraints from the menu, and enter the appropriate properties. Select OK, and you will see the anchorage drawn in the model in green. Now let's say we want to make some more complex modifications. We want to modify the building by cutting back the upper stories on 2 of its corners. Select all the members you wish to remove. Be careful here, but remember, in cases where geometry is congested, you could simplify by hiding the extraneous members. However, once you have got them all selected, click Delete on the context menu, and then go ahead and admire your handiwork. Next, we may wish to add braces or other members to the structure. Put the software into the draw mode and then click between the node members where you wish to place other members. Note how the braces automatically break and reconnect where they cross. We do the same thing on the second floor. And for the third floor, we may prefer to copy the braces from the second floor. Simply select, pick Copy from the menu, fill in a bit of data, and we now have bracing on the third floor. So let's now propagate this the entire bracing system to the opposite side of the building. Again, it's a matter of selecting the elements, picking Copy, And there we go. The bracing system has now been propagated to the other side of the building. And by the way, don't worry if you do something wrong. There are no permanent errors since CloudCalc has unlimited undo and redo. Okay, it's time to add loads to all the beams. It's easy to select all the beams either by function, name, or in this case, member type. Once selected, we can add some uniform loads. We can assign each load to one of 8 categories such as dead load, live load, wind load, snow load, etc. Or we can manage them by giving them individual names such as slab or facade, people, furniture, etc. Let's also add some wind loads. We'll select the columns along this one wall. Don't worry that we've also selected some beams along with those columns. We can simply indicate when we add our uniform loads that we only wish to apply it to the columns in the selection set, such as here. So we apply the magnitude, indicate that's a wind load, and save. So now let's take a look at these loads graphically to make sure that we have applied them correctly. The dead load, we have the magnitude, it's only on the beams, that looks good. The live load shows a magnitude of 40, also applied to the beams, correct. And finally the wind load, only against those columns on that one side of the building, that's correct. Everything looks okay. So now it's time to set up our load cases. Go to Input, Static Load Cases, and you'll see each individual load case will consist of specific combinations and multiples of design types. For example, 100% dead load, 125% live load. You can specify which code methodology to use and whether nonlinear effects are activated or not. You could build those all of your load cases individually, or you can let CloudCalc build them as per the requirements of the ASCE 7 standard. Here we see that based on the load types that we have defined, ASCE 7 requires 4 different load cases, various combinations of building self-weight, dead load, live load, and wind load. Okay, 5 minutes in, and we're already ready to analyze. So let's do a static analysis. The results usually come in fairly quickly, which they did, and because they're done on the cloud, the calculational time is the same whether you're using a computer, a tablet, or your phone. Results are returned in the form of displacements, forces and stresses, reaction loads, and code checks against the AISC code requirements. You notice that when you look at the code compliance report, it's accompanied by a color-coded compliance graphics. Green indicates passing, red indicates failure, and blue indicates that it's okay, passes, but it's very close. As you've seen here, most of the columns fail on the first 2 levels, along with some of the braces during load cases 2, 3, and 4. So let's try to fix these failures. The quickest solution may be to switch out the failing members for larger members. So first we want to select the lower 2 levels and specify that we only want to change out the columns in that selection set. And then we go ahead and change the columns from W10 by 54s to W10 by 112s. And if you look closely, you should see a slight change in the size of those columns. Now let's try the same with the braces. Let's change them out from a double angle 3 by 3 to a double angle 4 by 4. Okay, we don't see much different there. So let's go ahead and check, and a double angle 4 by 4. Okay, so let's run our modified structure and check the results. We've got the results back. Check code compliance. Case 1, all green, pass, fail. Next, all green, sort, pass, fail. Case 3, everything passes. Maximum, again, pass, fails. Therefore, it looks okay. So it's now time to release the calculation and sign off at it. A formatted printout of the input echo and all the results is just a click away. By the way, if this appears to be a lot of paper to generate, and I think we have 143 pages here, it's easy to limit this report to just a selected subset of nodes and elements of interest. So what's left to do? At this point, you may wish to share your calculation with your colleague at the construction site. How many times have you been required to give an engineering opinion or okay a change at the site, having access to no more information than your experience or your gut feel? Now with CloudCalc, any project team member can finally have access to all the calculations from anywhere on any device. Just name that colleague one or more, grant them sharing rights. So now let's move to the job site. Let's say your colleague has been asked to approve a change, and interference has made it impossible to install some of those braces. The site engineer, from right in the field, can call up the original model and calculation on a tablet or even a smartphone. Simply log in on that device's browser, and you get a mobile-friendly variation of the software within seconds. You can do just about anything you can do on a computer: review calculations, build models, make modifications, do analyses on the mobile version of the software. So it makes it very powerful to bring information and solutions to any place. Okay, let's locate that shared model. Click the box to include shared models, and there it is, model new, shared by Tom VL. The options here are to open it or to copy over for our own private version of the model, and I'm going to do the latter here. First, we may wish to reanalyze to give the site engineer a sense of the current loading state in its current design condition. But we can also make any modification that we could have made on the computer in order to make it easy to evaluate alternatives. For example, as it was mentioned, braces at this one particular location. Right here may not be able to be built. It is easy to evaluate design alternatives using CloudCalc. For example, we may wish to just remove the braces and evaluate the impact of leaving them out altogether. So we selected and then hit delete, and then we hit reanalyze. Looking over the results, the code compliance, we find that everything passes, case 1. Likewise, case 2. Likewise, case 3. And likewise, case 4. So it appears that the structure works just fine without them. Thus, an informed decision can be made on site much more quickly in a situation where time is money. So let's review the advantages of CloudCalc. It's easy to access from anywhere, including your office, your home, your client's office, or while on a business trip. Updates appear automatically without needing to install anything or without needing to rely on the services of IT. It's easy to learn and easy to use. It has powerful and flexible modeling and analysis capabilities. It promotes collaboration by enabling sharing among the project team. It supports mobile devices to bring informed solutions anywhere. And there are no perpetual licenses, but licenses which fit your and your company's workload. So why not go over now to www.cloudcalc.com and check out the program for yourself. Sign up now and you get a 1-month evaluation free. Thank you for your time. Thank you for your interest in CloudCalc. Hope to see you there.